Hello everyone, this is Mr. Smith. I'm back to finish off our talk about ionic compounds in terms of the formula writing is done, and now we're on to naming these compounds. And so there are kind of 6 rules to it. They're more about steps/rules, and we'll kind of talk through those together. So here, for example, we have Mg, which stands for magnesium, and O stands for oxygen. Now, to come up with a formula, you need to track down the charges and crisscrossing and reduce, maybe parentheses, maybe not. For the namings, it's much more straightforward. The cation is always written first, which is, again, in this case, the Mg. So that tells us magnesium. You can use your periodic table to do that. Magnesium, and then the O. So O is oxygen. Except that's not how it's named. If you look at rule number 2, the metal stays the same, so that's magnesium. Rule number 3, the non-metal changes to an IDE ending. So instead of ox, it becomes oxide. And there's actually a list of rules of how each element kind of changes. So I'm going to do a few, and then I'll kind of show those name changes off to you, and then you can kind of use those for later on. So here comes barium. So well, actually, before we even finish that, this is it. This is magnesium oxide. Step 4, no subscripts because it's not a formula, it's a name. Step 5, you do need Roman numerals if you're not using all those yellow variable. If you are using all those metal variable charges, so all of these yellow ones need to have some Roman numerals. But magnesium being in the second column is always 2+, so you don't need a Roman numeral to be told what the charge is because the second column tells you what the charge is. And so when a chemist says magnesium, we instantly know it's 2+. When a chemist says oxide, we instantly know it's 2-. So you don't need Roman numerals for those. And then step 6 is a polyatomic, and we'll get to that further down the sheets. But for now, let's talk about Ba and F. So Ba is barium, Ba-R-I-U-M. Again, that's just straight off the periodic table. And then F. So F is fluorine. And again, rule 3, we don't have element names on the periodic table in terms of the nonmetals at least. The metals get to keep their name. The nonmetals change a bit. This way, it's not just a list of elements: barium, fluoride, barium, fluorine, oxygen, nitrogen. We're not trying to list elements. We're trying to make a concise ionic compound. So instead of barium fluorine, it's barium fluoride, IDE. And that's it. That's barium fluoride. Again, barium is in the second column, so I don't need a Roman numeral. Fluorine is always -1 or 1-. So again, there's no Roman numeral necessary. It's all the uncertain metals where we need the Roman numerals. And barium is a certain +2. So NaCl. Na, let me click a little lower. Na is sodium. The metal keeps its name according to the second rule. The name of the metal stays the same, sodium. And then Cl, that's chlorine. On the periodic table, rule number 3 says IDE ending. So no INEs, IDEs, sodium chloride, good old table salts. Last one is done as an example. So K is potassium. 2 S's, and then I. So I is iodine, and again, instead of a N, it's a D, potassium iodide. And that's it. Again, I don't need Roman numerals. I don't need formula numbers. I don't need any numbers at all. Potassium's in the first column, just like sodium was in the first column, always a +1. So the name implies the charge that you need to crisscross with. And then the iodide, same thing, 1-. The anions never get Roman numerals. The polyatomics never get Roman numerals. The only thing that gets Roman numerals are all these yellow metals over here. So before I move on and show you kind of how every element, every nonmetal has kind of a different cutoff point for naming purposes, I do want to work with some polyatomic ions. So MgNO3. So NO3, if you look over here, NO3 is just nitrate. And so that's all we're going to have over here is just nitrate. Mg is just magnesium. Magnesium. And NO31 minus is just nitrate. And that's it. So no numbers, no Roman numerals, no crisscrossing, no parentheses, just the cation magnesium and the anion nitrate. The same thing for CaCO3. Ca is just calcium. CO3 2 minus, that's just, and I'll pull it over. Over here, CaCO3, that's carbonate. And so that's what I'm going to type down, carbonate, calcium carbon 8. Now you'll notice the different ending, ATE, that implies polyatomic ion as opposed to all these IDE endings. So there are a couple of polyatomics that have an IDE ending, but most of them are ite or 8, ATE, ITE. But notice it's not just carbon, it's carbonate. Carbonate gets synced with CO3, 2 minus. And just this name here is enough for me to go ahead and crisscross to get the ionic formulas that we've been working on before. So we have a few down here to try, and it's really the end game here is to be able to just have cations and anions. You give us the formula and give us the ionic name. All right, so here is a list of how all of the nonmetals become anions. So you have the full name hydrogen, just the first syllable is kept. So they all end with IDEs. It's just a matter of what part of the element stays and what part of the element gets dropped off, what part of the element becomes IDE. So for the most part, it's the last syllable or two that gets the IDE ending. So hydrogen, 2 syllables gets dropped to get hydride. Nitrogen becomes nitride. Phosphorus becomes phosphide. Oxygen, oxide. Sulfur, sulfide. Selenium becomes selenide. Fluorine becomes fluoride. Chlorine becomes chloride. Bromine becomes bromide. And we kind of say that on purpose, the enes. So even though this is spelled I-N-E, we still pronounce it fluorine, chlorine, bromine, iodine. This way it's different from fluoride, chloride, bromide, iodide. And so we have that kind of on purpose. So when it's said kind of quickly, it's enes versus ides. And there's kind of a couple more that's not on this list. As I look over here and kind of know off the top of my head, Si, silicone becomes silicide. Tellurium, there's actually a town called Telluride in Colorado. There's even a car called a Telluride. That's about it here. We'll try to stay away from those. But I'll just go back to this, take a screenshot, kind of have it nearby. We're not going to be overly harsh with the grading, but at the same time, as we try to input these into Edge Elastic, very specific with the grading and the spelling of it. So kind of keep this handy and have it with you. Well, we have some practice here, so let's do some of this practice together. So francium is in the first column. See if I can pull that up. Here we go. Here's francium in the first column. So that goes over here. Let me write it down. So francium's in the first column with a 1+. Oxygen's off to the side. Oxygen's over here with a 2-. It's kind of best to go through all these, but I'll do a couple, and then we'll kind of go a bit faster of a pace. So here's francium with a 1+, oxygen with a 2-, and now we crisscross that to get the formula FR2O. And then the name of it is francium keeps its name, francium, and oxygen becomes oxide. All right, francium oxide. Now ammonium is a tough one, a little bit of a trick. That's why it's on the practice and not the actual worksheet. Ammonium kind of looks like and sounds like an element, but it's not, right? So ammonium is the one polyatomic ion down here that has a positive charge. All of our other polyatomics are negatively charged anions. We have one positive polyatomic, and that is ammonium. So that should stand out a little bit as kind of a trigger to kind of hesitate a bit. So ammonium, NH4 plus, chlorine Cl1 minus. And so when I crisscross that, I get NH4Cl. The ones kind of crisscross and reduce themselves out of it. And my handwriting is not as great as I want to be, but I'm going to try to get better quickly. Cl. Now again, polyatomics keep their name, so this just ends up being ammonium. And Cl chlorine, INE, becomes chloride. CHLORIDE, ammonium chloride. They use this in cold packs. Francium oxide doesn't really exist. Francium's too radioactive to exist. So we're going to kind of keep at these. You're welcome to try these on your own and then kind of keep at it yourself. I'll pick up the pace though. All right, sodium is +1. Carbonate is CO3 2 minus, capital C, capital O. So when you crisscross that, we get Na2CO3. And then naming, sodium is sodium. Carbonate is carbonate. Now from this name, sodium carbonate, you could get this formula. From this name, you can get that formula. Even over here, cesium nitride. That IDE gets replaced. And so that name can give you this formula because you know cesium is a 1 plus in the first column. You know the nitride is actually nitrogen, and that's in the 3 minus. And so you can go ahead and crisscross that, CS3N. Now cesium has a couple of different spellings to it. So on your periodic table, there's an A there. I feel like that's far less common than what's out there. And I don't know if it's a typo or just a different way of spelling it. But most of the time I see cesium is with no A there. So that's why that's here as well. Now iron 3 nitrate. So iron, now the Roman numeral does change. Does stay with it. Up because we need to know that charge. This name has to give us the formula. Now nitrate does not change. And so now you kind of track these things down. Iron is Fe. That 3 means a 3 plus. Nitrate is NO3 1 minus. Again, have that periodic table handy. And now you crisscross this as you did on the prior video. Fe, NO3. This 3 goes down here. We don't like it to look like 33 oxygen, so we put parentheses in between the 3's and encompass the NO3. So now there's 1 iron and 3 nitrates. Last but not least, copper 2 sulfur. So copper 2 stays the same. Copper 2. And then sulfur becomes sulfide. All right, copper 2 sulfide. Copper 2 is a copper 2 plus. Sulfur is a 2 minus. Now you can crisscross this, Cu2S2, and then you can reduce those 2's into 1s, so 1s gets dropped. So CuS. And again, it's all a matter of this formula getting this name. And so this is the transition you'll be able to do, going from name to formula, not only now, but throughout the year. Start kind of sounding like chemists with being able to say chemical formulas. So good luck with your practice, and remember, chemistry is everywhere.